I'm Jay, and as you can see, today we're going to be doing integration by parts. Integration by parts is a special rule used when integrating the product of two functions. This is the formula that we use to solve integration by parts. But also, per usual, we have to derive this to understand where it comes from. So first, we start off by writing y is equal to a times u, a and u being two different functions. We take the derivative of those using the product rule, as seen in the second step. When we write the derivative of au, the two functions, over dx, that's taking the derivative of that, and then the product rule is seen as function a times the derivative of function u plus function u times the derivative of function a. And then in the second step, we take the integral of that, and when you take the integral of something that you just take the derivative of, you get the original equation. That's why you see the leftmost part simplifying to a u, and then that is equal to the integral of a times the derivative of d, the derivative of u over dx, and then the integral of u over the derivative of a. So yeah, that's what you get, and then with a little algebraic manipulation, you get the original equation that we got before. Yeah. Now that we have derived the function and have a solid understanding, it's probably best if we start to learn how to use that function, right? So we're gonna start off with a relatively simple one. We're gonna do the integral of x times cosine x. So right off the bat, we gotta go back and remember that there's two functions in the integral by parts equation that we use, and so we're gonna have to define both of the parts that we're multiplying by into two different functions, and the letters we used for those functions previously were a and u. So I'm going to define a as the function x, and then u as the function cosine of x. So in the previous equation, it was written as, in the integral by parts equation is written as something like the integral of a times, what is it, the integral of function u, so au dx. And so we're going to define this as, define this a as x, and then this cosine of x is going to be du of x, and from that we're basically going to solve the rest. We're going to fill in the rest of the problem. So if the next part of the equation is just a u, so we already have a, which is x, and u is just going to be the antiderivative of cosine of x, which is it's just sine of x, and then the next part is minus the integral of, oh wait, I got the x right there, minus the integral of what is it, u times the integral, the derivative of dA over the integral of a function a. So we already said that u is just going to be sine of x, and dA of dx, since we define a as x, the derivative of that is just merely going to be 1. And then, you know, constant in the integral factors out, and you just really just get sine of x. The integral of sine of x, which is negative cosine of x, and then x minus x sine of x minus negative cosine of x, which is really is plus cosine of x. And don't forget that plus c, folks. Easy mistake to make. For special example 1, we're going to be taking the integral of x squared times e to 3x. So first we're going to start off by saying our original two functions, a and u. We're going to define x squared as a, and then we're going to define, well, e to the 3x is going to be equal to the derivative of u, so we're going to take the antiderivative of e to the 3x, and that's going to give us 1/3 e to the 3x, and then we're going to subtract that from the integral of 1/3 e to the 3x, so that's going to be function u, and then the derivative of x squared, which is 2x. Now notice that we have basically another two functions, so we're going to have to repeat the integral by parts equation again just for this part. So we're going to once again define the simpler term as a. So we're going to define 2x as a. We're going to say 2x is equal to, and then times this, the integral again once of this, because this is going to be equal to the derivative of function u. So it's going to be actually 1/3 times 1/3, so it's going to be 1/9. And actually we can just multiply that by the 2 to give us 2/9 x times e to the 3x, and then subtract that from the integral of this, and it's going to give us 1/9 e to the 3x times 2, because it's going to be the derivative of this, which is just going to be 2, so we can just multiply this 2/9 by that, take the antiderivative of this, and we're going to get 2/27e to the 3x minus 2x over 9 times e to the 3x, and that's all going to be equal to this original part, and then you just plug in the rest of the equation. That gives you your entire solution: x squared e to the 3x, and then oh no, my bad, 1/3 x squared e to the 3x, and also this is going to be plus, and this is going to be minus because it was originally subtracted anyway, and you just add that plus e in there, and boom, we are good to go. Yeah, that about concludes our time here in Math Gang with Jay. See ya, Peyton.